we continue the second part. So for the second column, first, nickel was input into the column system and followed by a cadmium. And the third column experiment is nickel and cadmium mixture was input this column together. So this is a result of a discussion. For nickel single applied into the column experiment, we saw that this is a nickel breakthrough curve. We saw very strong retardation. The same thing also for Olivier. And the transport behavior is non-equilibrium transport. Then when we apply nickel first and followed by cadmium, we observed a concentration drop at absorption site of nickel breakthrough curve. Here, very strong concentration drop. This also was observed at winter soil column. A concentration drop was observed here after cadmium was applied into the column system. Here we have a little discussion. If cadmium applied into the system can exchange the nickel out, then the nickel concentration would increase rather than decrease. So, but the truth is we observed concentration drop. How this happened? Because nickel was absorbed more onto the soil column. That's why the concentration dropped. What's the reason? That's why cadmium was applied into the system. The cadmium make the nickel absorb more in this system rather than exchange the nickel out. So that's here we little discussion. The third column design for each soil is this is a nickel and cadmium mixture applied into the soil column together at the same time. So we saw less retardation or no retardation here. This is also happened for winter soil. And also the nickel and cadmium present in the column at the same time make the nickel ore column transport behavior change from non-equilibrium transport to equilibrium transport behavior. After the column experiment, the sequential extraction was conducted. We saw nickel soaked on soil with 4 fraction, exchangeable, iron aluminum fraction, organic fraction, and residue. We refer the exchangeable fraction as non-specific sorption, and also the total amount of other 3 fractions we refer to the specific sorption. So here is the result of sequential extraction. The blue is the single element applied into the column system. The yellow is the nickel first and followed by cadmium. The purple is nickel and cadmium mixture. We observe here the exchangeable fraction was decreased when the computation present, and the specific sorption increased when the computation present. The same was also observed for Olivier soil. See, this is exchangeable fraction when the computation present decrease compared to the single element column. The also specific fraction increase when the computation present. Conclusion. separately evaluate the effect of competition on non-specific and specific sorption is necessary. The competitive effect of nickel and cadmium during the transport in soil column can suppress the non-specific sorption due to competition for common reaction site. Here, competition at relative lower affinity site. That's we observed as non-specific sorption was decreased. Such competition also forced nickel to be sorbed at more specific sites. It may cause metal stronger bond at higher affinity site. The limited sorption of heavy metal gives the potential discrepancy of the competitive effect on non-specific and specific sorption, which resulted in a different equilibrium time and transport behavior in the presence and absence of competition. That's the whole slide. Thank you so much. And then give some suggestions and comments. If you have any question, send email or call me. We can discuss more. See if this can help you understand this whole paper or the whole idea of this experiment. Thank you.